Hello, Algebra students. In today's asynchronous session, we're going to learn how to graph inequalities in two variables. Alright, so before we do that, we need to define a few key terms. What is a linear inequality? A linear inequality looks exactly like the equation of a line, but it has a symbol, an inequality symbol, like greater than or less than or greater than or equal to, rather than the equal sign. So it is the equation of a line, but with a few changes that we're going to talk about soon. What do I mean by slope-intercept form? All right, so as you've seen in previous lessons, the slope-intercept form is the equation of a line that has the form y equals mx plus b, right, where the m and the b are numbers. The m is the slope, and the b is called the y-intercept. Okay, so what are the differences between graphing linear equations, that means just a straight line, and graphing a linear inequality? Well, they're very similar, but they only have two differences. One, there is shading involved when we're graphing inequalities, right? So half of the xy coordinate is going to be shaded, right? And lines can either be represented as solid lines or dashed lines, and that's the other difference. Everything else is pretty much the same. So what should we use, what form should we use to graph? All right, well, when we're graphing inequalities, we need to use the slope-intercept form. This will help us determine where to shade the graph, and we'll talk more about that later. All right, so if the inequality is not in slope-intercept form already, then we need to rearrange that inequality so that it is in slope-intercept form. Now, when we solve an equation, when we rearrange an inequality to get it into slope-intercept form, we do everything the same as we would in solving an equation. In this case, we want to get the y all by itself, with one difference. When we divide or multiply by a negative number, right, when we're dealing with inequalities, we got to remember to switch the inequality sign, or to flip it. So let's do a few examples. So let's rearrange the following inequality so that it is in slope-intercept form. Suppose I have the inequality x minus 2y is less than or equal to 8. I'm trying to get this into slope-intercept form. That means I'm trying to get the y by itself on the left-hand side of this inequality. All right, so in order to do that, the first thing I need to do is isolate the term with the y. So what's with the y on the left-hand side of this inequality is the term x. So the first thing I need to do is move that x to the other side of the inequality. It is a positive x, so I'm going to subtract x from both sides. So on the left-hand side, I'm left with negative 2y. And on the right-hand side of this inequality, we now have negative x plus 8. Notice how I kept the negative with the 2. Right? That sign doesn't move. That sign doesn't change. All right, so it was negative 2 before, and it's still negative 2y now. I also wrote the x, and I could have written 8 minus x and put the x at the end. But to make it look like the form that we're used to seeing for the equation of a line, remember we have y equals mx plus b, we usually have that x term written first. Mathematically, it doesn't matter. It's just a form that we recognize more often. So I go ahead and I rearrange the terms, and notice I have to keep the sign with the x. So it's negative x here, and this is a positive 8, so I write negative x plus 8. All right, so we're not done yet, right? Because y is not isolated. Y isn't by itself. So we need to get rid of the negative 2, which is being multiplied by y. So we think back to our inverse operations and we decide, how do I undo multiplying by negative 2? Right, and the answer is to divide by negative 2. Right? The opposite of multiplying by negative 2 is to divide by negative 2. And notice I have to divide every term by negative 2. All right, so dividing by negative 2 on the left-hand side of this equation is what isolates y. And then now I go ahead and I make sure to follow the rules using multiplication and division with integers. And here a negative divided by a negative is a positive. And I just left it as positive x over 2. You could have also write that as 1/2 x. And 8 divided by negative 2 is negative 4. What I want to point out, though, what I really want to point out when I've written this equation is notice how originally the equation, the inequality symbol was less than or equal to. And then in my last step, it changed to greater than or equal to. That is not a mistake, right? When we multiply or divide by a negative, we have to flip the inequality symbol. All right, and it's not the fact that over here, like this 8 became a -4 because we divided by -2. You know, that the answer that we get over here doesn't determine if we flip it. It's the step that we do to get the y by itself. So in this case, to get y by itself, the action I had to take was to divide by a negative. So whenever we divide by a negative, we have to flip the direction of that inequality symbol. So it did become greater than or equal to. All right, so that's an example. Let's try another example. See if you can take this inequality and isolate y. Get y all by itself. That is, rewrite this inequality in slope-intercept form. Take a moment to pause the video and try this on your own. All right, so I'm going to start by trying to isolate y. All right, so if there was any like terms on the left-hand side of this inequality, I would combine them, but there isn't. So I'm just going to go about moving the other terms to the right-hand side of the inequality. So in this case, I chose to move the -4x to the other side of the inequality by doing the opposite of subtraction, which is addition. So I went ahead and added 4x to both sides of the equation. Notice I'm not just adding 4. I'm adding the entire term. It is with that x. I can't break it apart just yet unless I want to divide it by 4. Right? So it's a group. It's together. They're stuck together. We call it a term. Right? All the things that are separated by plus or minuses is a term. So I can pick up an entire term, right, and add or subtract it, whatever I need to do to move it to the other side of the equation, or in this case, inequality. So I see that we have a -4x. So I get rid of that. I push it to the other side by adding 4x to the other side. So after I do that, I have that y plus 2 is greater than or equal to 4x plus 8. Y is not isolated yet. Y isn't by itself. Notice I separate this inequality into two separate expressions, where on the left-hand side we have y plus 2, and on the right-hand side we have 4x plus 8. So I separate them by the inequality symbol, and when I refer to the left-hand side, I mean what's on the left of the inequality. And when I refer to the right-hand side of the equation or inequality, I refer to what is to the right of the inequality. So finally, I'm still trying to get the y by itself. There's one last step. Y is being added with 2 on the left-hand side of this inequality. So it's that 2, it's that extra term that I need to push to the other side by using inverse operations. So if it says plus 2, we subtract 2. And we have to do that to both sides of the inequality to keep it balanced. And remember what are like terms. I can't subtract 2 from the 4x because this 2 doesn't have an x with it. All right, so the 2 can be subtracted though from the number 8. Since they're both numbers, just numbers with no variables or letters, I can add or subtract them. So they are what we call like terms. So I can do 8 minus 6, 2 to get 6. Notice I didn't divide or multiply by a negative this time, so that we didn't have to change the direction of the inequality symbol. So our final answer is y is greater than or equal to 4x plus 6. I want you to focus again on why we're doing this in the first place, right? Because what our goal is here is to be able to graph this two-variable inequality, right? So we're going to have an xy plane and we're going to graph it. But before we can graph it, we need to have it in this form. We need to have it in the slope-intercept form, where instead of an equal sign there, right, there's an inequality symbol. When we were just dealing with lines, you didn't necessarily have to have it in slope-intercept form to graph it. You could graph it in the standard form. You could graph it in the point-slope form. But in this case, it's essential that we get it into slope-intercept form first, so that when we decide where we need to shade the graph, we know where that is. So what do I mean by that? All right, so once it's in slope-intercept form, all right, only the inequality symbol itself decides where we shade and what the line style is. So I saw a lot of discussion questions where people thought perhaps the sign of the slope had something to do with it. If the slope was negative, it meant shade this way, or if the slope was positive, it meant shade that way. That is incorrect. Where you shade and what the line style is depends only on the inequality symbol once the inequality is in slope-intercept form. So I want you to take a moment and copy this table into your notes. All right, because this table and this table alone is going to allow you to graph inequalities the exact same way that you graphed the equation of a line. So here we can see that whenever an inequality is greater, whether it's greater than or equal to, I wrote that the shading is above, and we'll talk more about what that means later. Whenever the inequality symbol is a strict inequality, meaning greater than or less than without the equal with it, just strictly greater than or strictly less than, the line style or the border line is going to be dashed. Whenever we have the or equal with it, doesn't matter if it's greater than or equal to or less than or equal to, the line style or the border line is going to be solid. And kind of an easy way to remember this is greater than, both of these symbols, whether it's greater than or equal to, shading above, greater is above, it's more. Less than or equal to, shading is below. Less than means less, means below. And then if you have the line underneath the inequality, if you have the or equal, that's when you get the solid line. Otherwise, you get the dashed line. So what do I mean by that? Let's take a look at this graph of an inequality. This is in fact the graph of the inequality y is less than 2x minus 1. So when I was talking about the border line being dashed or solid, this is what I'm talking about. You can see what I'm talking about now, that the line itself, in this case, is dashed. It's dashed because this inequality is less than without the equal underneath it. Right? If we don't have the or equal underneath it, then it's going to be a dashed line. All right, so it's a dashed line, and we can see now what we're talking about. The next question that we have to ask ourselves is, where's the shading? And from the table that we just looked at, right, less than meant below. So now we just have to decide what below means. And when we're saying below, one way to think about it is shaded below the line. And if you're unsure exactly where that is, go to wherever the y-intercept is. In this case, it's at -1, because the y-intercept is -1. And then say the shading should be below this. Okay, so that means down here. And we shade the entire line on that side. So shaded below the y-intercept. Now you can see that we're shaded below. So that's what I mean by what the border line is. Is it a solid or dashed line? And is the shading above or below? In this case, it's below. If I shaded up here, it would be, we would say that that was shaded above. Now it's very important that you think of this in terms of below, shaded below, versus and shaded above versus shaded left and right. You know, I see a lot of students also make that mistake when they're thinking about the shading. They're trying to think about it in terms of left and right instead of up and down, right? Do not think of it in terms of left and right. The reason why we're not is because notice how we isolated the y. We got the y by itself. So I'm describing this inequality in terms of y, which is the vertical axis, which is up and down. All right, so when I say y is less than something, I'm talking about up and down. So y is less than, below on the y-axis. The x-axis would be left and right. So if you think about it in terms of left and right, you're also going to make the mistake of where to shade. Depending on the slope of the line, it changes if it's greater than or equal to. So it's real easy to make a mistake that way. So I want you guys to think about it only in one way. That way is the shading is up or above or down or below. Above and below. All right, so how do we graph this inequality? Y is less than or equal to negative 4x plus 7. Well, remember there's two questions we need to ask ourselves. One, is it going to be a solid or a dashed borderline? And then two, where the shading's going to be. And then everything else is identical to graphing a line like you have in the past lessons. All right, so now I'm looking at this symbol. I'm looking at this inequality, and I'm seeing that it's less than or equal to. I see that it has the or equal to, so I know that it's going to be a solid line. All right, so back from the table that you copied down in your notes, you can see that when I have the or equal, the line's going to be a solid line. Now I have to decide where to shade. Are we going to shade above or below the line? Well, I can see this inequality, and remember this one means less than or equal to. Less than means below. Less is lower, below. All right, so in this case, the shading is going to be a solid borderline with the shading below. So if you can answer those two questions when you're trying to graph any of these inequalities, you're going to have half of the answer, and especially when you're taking your multiple choice type quizzes or these things, tests on the computer, just looking at that inequality symbol can at least rule out half of your possible answer choices right off the bat, if not give you the answer itself. Because you can look at them real quickly, and even if you don't know how to graph the slope or the y-intercept, you can go, wait, option C is the only one where the shading is below with a solid line. Oh, so it must be that one. So you can use that kind of information really to weed out a lot of your choices when you're taking these kind of standardized tests. All right. So in this case, we know where the shading should be and how the borderline should be solid or dashed. So take a look at this inequality. Take a moment to ask yourself, should this line be a dashed line or a solid line? If you said dashed line, congratulations. Right? This inequality is strictly greater than. We don't have the or equal underneath it, so I know it's going to be dashed. Then we have to decide, is it the shading going to be above the line or below the line? All right, and in this case, since it's greater than, this symbol is greater than. Greater than means above, so we know that this inequality is going to be shaded above the line. Right, remember this only works when I have y all by itself on the left-hand side, right, when we have it in slope-intercept form. All right, so here's an inequality. I already have it in slope-intercept form, so I'm going to go ahead and decide where the shading needs to be and what the borderline style is. So first I decide, is it a solid line or a dashed? And correct. In this case, since we have the or equal with it, it's going to be a solid line. And then we decide where we need to shade. Well, I guess we need to shade, is it above or below? If you said above, congratulations, right? Greater than or equal to, the shading is above. Pretty easy to remember that greater is above and below is less, because that's what those words mean themselves. So let's go ahead now and use this information to actually graph something. All right, so let's remind ourselves how to graph a line. So in this case, consider the inequality 3y is less than negative 6x plus 9. And we're tasked with graphing this inequality. The first thing I look at is, I ask myself is this inequality in slope-intercept form? Do I have the y all by itself on the left-hand side of this inequality? And in this case, I don't. Look, it's being multiplied by 3. I have 3y on the left-hand side. I want just y. So now I need to undo multiplying by 3. And the operation that we do to undo multiplying by 3 is dividing by 3. When I'm drawing this line here, I'm not just drawing a line to separate two items. That line means something. That line is implying the operation division. So this does mean divide, right? If I was subtracting, I would show you the little minus sign. But in this case, I have a line because I'm dividing. And when you divide by 3, I have to divide every single term by 3. So 3 divided by 3 is 1. That cancels, giving us our y, isolating the y on the left-hand side like we wanted. And then I went ahead and divided -6 by 3 to get -2, and 9 by 3 to get 3. Notice I left the inequality as less than. That's because I divided by a positive 3. Remember, I can divide by a positive number. I don't flip the inequality. You can also add or subtract anything you want. That doesn't flip the inequality. It's only when your action to get the y by itself, right, is to multiply or divide by a negative, that's when you flip it. And here we didn't divide by a negative, right? We divided by a positive, so it didn't flip. All right, so now we have finally our equation, inequality in slope-intercept form. And remember the two questions I asked. Right? The first one I ask is, what style of borderline are we going to have? Is it going to be solid or dashed? Well, in this case, I have a strict inequality, meaning just less than in this case. So less than means dashed. So I know it's going to be dashed. Now that I've figured out it's going to be dashed, I go about graphing this line, this inequality, the exact same way I would a line. So I kind of like pretend there's an equal sign in there. And when we have something in slope-intercept form, the first thing I do is look at that y-intercept, that number at the end here, in this case the 3. And I go to the y-axis and I put a dot there, right? Then I use the slope to get my next point. So if I was graphing this, here, let me pull out my pen. Right, I would go right to where 3 is on the y-axis, because that's the y-intercept, because here it is here, here's the y-axis. And then now I know that the slope is -2. Another way to write a whole number, right, is writing that whole number over 1. So we can write any integer over 1, because it's the same thing. -2 divided by 1 is 1. This is a little bit easier when we're doing the slope, because remember the top number is the rise, and the number in the denominator on the bottom here is the run. So the top number is the change in up and down, right, in the y-axis. And then what we call in the denominator, the run, that's the change in the x values to get from one point to another. So in this case, I've rewritten this slope of -2 as -2 over 1. And what that is telling me is to get from one point to another, I need to go down 2 and to the right 1. All right, so in this case, I start out with my y-intercept, my point on the y-axis at 3, and I need to go down to 1, 2, and to the right 1. Then I can put another point. Right? Remember, it only takes 2 points to define a line, because there's only one line that I could draw that would connect those 2 points, that would go through both of them. So now I have enough information to go ahead and sketch my line through those 2 points. And I utilize the fact that this line is going to be dashed, so I make it a dashed line. All right, so now we're most of the way there. We have one other thing to decide, where the shading is going to be. Okay? So in this case, I'm looking at the inequality symbol, and I see that it is less than. So less than means below the line. If it was greater than, we would shade it above. So when I say below, if I'm confused about where that means to shade, I kind of go to the y-intercept. So I kind of put my pencil on that point, and then I say, wait, where's below? Okay, well below is down here. So all this side of the graph should be shaded. And there, so we shade that. We call this shaded below. All right. Another way to do this, and they show you this in your lessons too, is to check a point. So instead of deciding, oh, the inequality says less than, so that means shade below, another way to do that is to pick a point and check it in the inequality and then see if you get a true statement or a false statement. So the point that they almost always pick, because it's the easiest one to use, is the point 0, 0. So imagine substituting 0 in for x and 0 in for y. And in this case, you would get the inequality that 0 is less than negative 2 times 0 plus 3. We're trying to figure out if this ends up being a true statement or a false statement. So if I consider simplifying this, I get that 0 is less than positive 3, right? Because negative 2 times 0 is 0. Then I ask myself, is that true or is that false? Wait, 0 is less than 3. Okay, so that's a true statement. So now that I know that the point 0, 0 gave us a true statement, it would mean that it should be shaded in. And in fact, that's what the shading means when we're looking at the graph. It means every single one of these points that is in the shading, what we satisfy this inequality. That means that if I plug them in for the x and y, I would end up with a true statement like this. So that's another way to check if your shading is correct. Try a point. Make sure it gives you a true statement. If it does, then you shade it in the right spot. If it doesn't, then you need to shade the other side. All right, so let's do another one. Let's graph this linear inequality. So we have that x minus 2y is greater than or equal to 1. Well, I can't just start graphing this one. Not yet, right? Because remember, the first thing we need to do is get that y by itself. That's why we practice doing that in the beginning of this lesson. Right? We need to isolate the y. And to get the y by itself, the first thing I'm going to do is isolate the term with the y. And remember, this is a term. Notice how I included the negative with the 2, right? I always make that, assume that the sign of the number is immediately whatever the sign is to the left, all right? So that's a term. So it's this x here over on the left-hand side of this inequality that needs to move, that we need to get rid of first, that we need to push to the other side. Notice right now we didn't write it, but this does mean positive x. If it was a negative x, they would have had to write negative x. So we want to undo plus x. All right, so to do the opposite of that would be to subtract the x term from both sides. Another way to think about it, right, is when I just have a variable, there's always an implied 1 in front of it. We just have an x, well, that means 1x. If we have a positive 1x, then I need to subtract 1x from both sides. So now that I've done that, I go ahead and I rewrite it so that the x comes before the constant in this case, so that it looks like slope-intercept form. Although you could write it at the end, mathematically it's the same. It's just easier if we have a form that we're easily able to recognize. So now the next step is to isolate the y by dividing everything by negative 2. So once I do this, what should I do with the inequality symbol? Does it stay greater than or equal to, or should I flip it to less than or equal to? The way I decide, or the way that you should have decided, is to ask yourself, what did you do to get the y by itself? Did you multiply or divide by a negative? Yes, in this case we can see that we had to divide by negative 2. Since I divided by negative 2, we flipped the direction of the inequality. So don't forget to do that. All right? Whenever you multiply or divide by a negative, you need to flip the direction of the inequality symbol. And then here, a negative x divided by a negative 2 is positive, right? A negative divided by a negative is a positive. So we get x over 2. And then I went ahead and divided 1 by negative 2. And that just means negative 1/2. All right, so I have these fractions. You know, another way to write this inequality here would be to say y is less than or equal to 1/2 x, written on the side like this. This means the same thing, minus a half. Now my next step would be to ask myself, is this going to be a solid line or a dashed line? Remember, these things are determined solely by the inequality symbol. All right, well, we have the or equal with it. All right, so that means it's going to be a solid line. Then I'm going to go ahead and start graphing this just like I would a line. And I know that in this case it's going to be a solid line. So remember, I go to the y-intercept. In this case it's negative 1/2. And I would put a point there, right there. Here it is on this graph, -1/2 on the y-axis. Now I'm going to use my slope to get my second point, and then I'm going to connect them with a solid line. Then finally we'll decide, do I need to shade above or below? All right, so this means in this fraction here, the numerator is the rise and the denominator is the run. So this is telling me to get from one point to another point, I need to go up 1 and to the right 2, since they're both positive. So I'm going to go up 1. All right, so right now, if we're at -1/2, which is, excuse me, right here, all right, so here is our y-intercept. It is at -1/2. It's right there. And now I'm going to go up 1. And going from -1/2 and adding 1 to it, I would become at +1/2. So I'd be like right here in between. Then I'm going to go to the right 2. So here's 1, 2. And I put another point right there. All right, so this is going to be roughly where this crosses. So I decide that I needed a solid line. So I drew a solid line, notice that, between those 2 points. Now next I have to decide where to shade. So we look at our inequality symbol and we see that it says less than. So that means I need to shade below. Less than is shaded below. So you can see here we shade it below and we've graphed our inequality. So one last practice. Graph this linear inequality. -4x is greater than or equal to -8x plus 16. Step 1. Get the inequality into slope-intercept form. It means I got to isolate the y on its left-hand side this time, and I got to do that in this case by undoing multiplying by -4, which is to divide everything by -4. When I divide by a negative, I had to flip the direction of the inequality. Remember, that's the only time you do it. Pretty much always you're just going to be dividing. So when you divide by a negative, just remember you got to flip that. That's the only time you're going to do it. Every time else, you leave it the same. So I divide every term by -4, and I get that y is less than or equal to 2x minus 4. Next, decide if the line should be shaded or dashed. Remember, that solely depends on the inequality symbol itself. And since we have an or equal this time, it's going to be a solid line. Okay, so now we know the line should be solid. The next step I do is to graph the line like as if the inequality was an equal sign. So I use the information. I use the y-intercept and the slope to graph the line. And in this case, the y-intercept is at -4. So I go to -4 on the y-axis. I put a point. I use the fact that our slope is 2, or in other words, 2/1, to get my next point. Remember, this is the rise, and this is the run. So this would imply to get from one point to the next, I need to go up 2 and to the right 1. All right, so I do that, and I plot another point. We already decided the line should be solid, so I draw a solid line through those 2 points. Then finally we decide where to shade. Since this inequality is less than or equal to, it doesn't matter if it was less than or equal to, right? Then that means shade below. All right, so shade below. And if I'm a little confused about what I mean by shading below the line, just go to wherever the y-intercept is and tell yourself, hey, the shading should be below this part. Okay, so that means down here. Then we shade it. What if I'm given a graph and I'm asked to write the equation of the inequality? Okay, so in this case, we're already given the graph, and now we're tasked with finding the equation. All right. Well, I go about and do this the same way I would if it was an equation instead of an inequality, with that one exception of deciding what the symbol should be. So to me, the very first thing I do is I look at the picture and I decide, well, where's the y-intercept? What's that b? Because remember, we're trying to write this. We're trying to write y equals mx plus b. All right, and we only need two numbers. We need to know the slope, the m here, which is the slope, and the b, which is the y-intercept. So I need to fill in those two numbers. And then the last step we're going to do is decide what inequality to replace this equal sign with. All right, but one step at a time. Let's get the y-intercept. All right, so in this case, the y-intercept is at 4. We can see that because this is where this line is crossing the graph. All right, so the y-intercept is at 4. Then I decide, next, what is the slope of this line? Well, I know right away because it's going downhill from left to right, that the slope is a negative number. But what is that negative number? And the best way I do it is just simply to count. So since we know what the y-intercept is already, I'm going to count down to another point that I can identify on the graph. You know, I don't want to go down to where it crosses like in between a corner because I don't really know what this number is right here. Maybe this is like 0.4, I'm not sure. But I'm trying to go where it crosses one of the corners so that I can easily identify that point. So to me, it crosses the corner right here at the point 1, 2. So I go ahead and I plot that point. You know, I put that point there again. Or in this case, I could have also gone and picked the one where it crossed the x-axis at 2, 0. Either one of these points would have worked. But as long as you can identify it, right, as long as it crosses a corner, you're going to be okay. And then I go ahead and I just count. Remember, I'm doing rise over run. So I got to go up and down first, and then left and right. So to get from this first point to the second point, it looks like I have to go down 4 and to the right 2. And so when we're going down to get from one point to another, that means negative. So we write negative 4 over 2. Then we can reduce negative 4 over 2 to negative 2 over 1, or just negative 2. Okay, so we know the slope. So remember our equation, y equals mx plus b. Let me remind you of that up here. This is what we're trying to find out. Y, it's going to be some inequality symbol we don't know. The slope, which we know now is negative 2. There's always going to be the x, and we know the y-intercept is at positive 4. We are so close to finishing this inequality. All we have to decide is what goes in here now, what the inequality symbol should be, right? If there were no shading, it would just be an equal. But in this case, we do have shading, so we have to decide what inequality it is. Well, since the line is solid, I know there's an or equal with it, right? It's either greater than or equal to or less than or equal to. Then I ask myself, where's the shading? Is the shading above or below the line? Well, in this case, the shading is above the line. And recall from your table that above means greater than. And it's solid, so it should be greater than or equal to. Then finally, we have every single piece of information we need to write the inequality in slope-intercept form. So take a moment to pause the video and see if you can write the equation of this inequality on your own. All right, so question number 1, where's the y-intercept? Remember, I tend to start out by writing the slope-intercept form for the equation of a line mx plus b, just to kind of remind myself. So I'm going to go ahead and write that up here. And then I'm telling myself, remember, y and x are always part of the equation. It's the m and the b that I need to fill numbers in. And m is the slope and b is the y-intercept. When I'm looking at a picture, the y-intercept is usually easy to spot. You know, you're looking at where it crosses on the y-axis. And for simplicity case, you know, we're usually going to make that a whole number for you guys. And if you didn't, you could always use a graphing technology like Desmos, and you could trace over it and find out what that number was. But here, look at this point. I can see that it is crossing at positive 1 on the y-axis. So look, I already know what this value is. It's a 1. Right? Then I'm going to go after my slope. I need to know what the slope is. So I need to be able to identify another point on this graph that crosses at one of the corners on the grid, right? Because that way I can identify the point. Like, I don't want to pick this point because, like, notice it's like in the middle somewhere between 1 and 2. And since I don't know exactly what that number is, maybe it's like 1.4, maybe it's 1.5, I can't use it. So I'm intentionally searching the graph for somewhere where it does cross at one of the tick marks, right at one of the corners. And I find my first point here. So I'm going to go ahead and use that one. Now I can count the slope. To get from this first point to this second point, how much do I have to go up? Well, we have to go up 1. Right? We already know the y-intercept is 1. Now what's the slope? I have to go up 1, and I have to go to the right 2. So I write rise over run, or 1 over 2. So now we know our slope. Now we know our m right here is positive 1/2. We're almost done. We decide that since it's a dashed line, that it's going to be one of our strict inequalities. It's going to be, in this case, either greater than or less than, because we don't have the or equal. And we can tell that, right, because it's a dashed line. And then we look at the shading. And we can see that the shading is below. All right, so below means less than. And since it's dotted, it's strictly less than, without the or equal. So then finally we can write the inequality, right? We know the b is 1. We know the y-intercept is positive 1/2. And now we know the inequality symbol that we need is less than. So once again, go back to your course announcements after watching this video and answer the 5 questions that are included on the Asynchronous Session 3 questions. All right, I'll be emailing and messaging you with more information if you don't know where to find that. But make sure that you submit those questions because that is how I grade you.